Hello and welcome back to HSC Maths Tutoring with Nathan, and today I'm going to show you a trick to turn two inverse functions into one inverse function, right? And that will appear in 3-unit maths, not too often, but it's not uncommon. So I've seen it quite a few times in past HSCs in the form of proof questions or even in motion questions. So let's look at the question. We want to prove that tan inverse a third plus tan inverse 2/5 equals tan inverse 11/13. So this is a proof question. So that means we got to pick left-hand side or right-hand side to start with. Now, in any proof, you always start with the side that has a lot more info, which is the left-hand side in this case. You think about it, it's going to be very hard to take one tan inverse and turn it into two. That's quite impossible, really. But it's a lot easier to take two tan inverse and turn it into one. So basically the trick here is we look at what the final answer is. We look at the inverse we want in the answer. So the trick here is whatever answer, inverse answer is, this could be tan inverse, sine inverse, cos inverse. We just sine, cos, oh that's shocking, or tan LHS. Depends on RHS. So if the right hand side is tan inverse, I'm going to tan. If it's sine inverse, I'm going to sine. If it's cos inverse, I'm going to cos. So what that means is I'm going to tan the left hand side like this. So this is something a lot of people don't realize you can do. Even though you're starting with left hand side equals and you're working with this, you're allowed to do whatever you want to this side, as long as you do it to both sides. So then, now I'm going to rewrite it like this. Because if you remember inverse trig, each inverse trig is an angle. So to simplify my working, I'm going to use the substitutions alpha equals tan inverse a third, beta equals tan inverse 2/5. And if we want, we can rewrite this as tan alpha equals a third by taking to the other side, and tan beta equals 2/5. So now if we look at this side, tan brackets alpha plus beta, this is an angle sum then. This is a 3-unit formula which we can just substitute in now. Get your formula sheet out, it's on the new formula sheet, and just sub it directly in. So we just write the formula down. And now we just need to compute what tan alpha and tan beta is and sub it in. Well, we don't need to because we know the values right there. So we can just sub the values for tan alpha and tan beta in straight away. Just a side note, if we didn't have one of the ratios, if you don't have one ratio, you just draw a triangle. So what that means is, if I have tan alpha equals a third, I'll use Pythagoras to complete it, and then from that triangle I can work out sine alpha and cos alpha if I needed those. And you do the same for beta. But in this question we already have the given values, so I'm going to just substitute it in here. Now at this stage you can either use a calculator to simplify it yourself, but a trick, but I'll go over in a future video. So this is called a compound fraction. So what we do is we times each single thing by the LCD, which is 15. So that turns into 5 plus 6. I'm just going to write what I'm doing here. Times everything by 15 over 15 minus 2, which equals 11/13. So if I write what I've got now, I've got tan LHS equals 11/13. So now we need to get LHS by itself. So to do that, we just tan inverse it. So we take the tan to the other side as a tan inverse. And what do you know? That's the right hand side. So that is the simple trick to turn two inverse trig functions into one. You just look at the right hand side, sine, cos, or tan inverse the left hand side depending what's in the answer, and then you're going to use an angle sum identity. And if you don't have one of the given ratios, you use a right angle triangle. So make sure to go through the video, pause it where you need to and take some notes. Otherwise, if you enjoyed today's video, make sure to give it a like and subscribe for future videos, and comment below what you would like to see in future videos. Otherwise, I'll see you guys next time.